Hi everyone, it's Mr. Baker here. Today we're going to be looking at the insulation required practical. Okay, so today I'm going to be using the Focus eLearning website, focuselearning.co.uk, to go through the thermal insulation required practical. And remember, what you need to be doing for these required practicals is you need to be able to write down a method that you could use. And then you also need to be able to analyse results and maybe evaluate those results as well. Okay, so there's a few things that you might want to do with this thermal insulation practical. You can change the type of insulator that you use. Today we're going to be looking at how the number of layers of insulation affect the time it takes for a beaker of water to cool down. So the equipment that you need for this experiment is you need to have a beaker of water and you need to have some kind of insulation. So it's probably layers of newspaper or something like that. So strips of newspaper that are cut to the right size that you can just put them on with elastic band or something like that. Then you'll need a thermometer and then probably a lid as well so that the thermometer can kind of stay in place. But as long as you keep it the same each time, it doesn't really matter if you've got the lid or not. And then you'll need some kind of stopwatch. So it's fairly simple what you're going to need. And then all you're going to do is you're just going to need to boil up your water, probably in a kettle. I suppose you could use a Bunsen burner and heat up the water to a certain temperature. And then you're just going to start your stopwatch, let the water cool down, and then every so often you're going to then take the temperature. So probably in a lab in classroom, you'd probably do it for about 15-20 minutes, and so every 30 seconds or every minute you would take the temperature and you would see how it cooled down, and then you'd have a number of these cooling curves that then you would be able to compare and then see how the insulation affects how long it takes for the water to cool down. So I'm just going to go through it once with you so you can see the kind of curve that you might get, and then we'll maybe look at the kind of conclusions that you might get from this, and then we'll finish. Okay, so we're going to start. So I've boiled up my water. It's 80 degrees. So at the moment it's 80 degrees, and then what we're going to do, the room temperature is at 20 degrees, which is probably about right. I've got a small mass of water so that it will cool down quicker. The larger the mass of water, the slower it will cool down. So that's another thing you could vary in your experiment. But here we're going to be changing the layers of insulation. So we're going to start off with no insulation at all, and to have the biggest range I can, I'm not going to put a lid on, although you can put a lid on if you want. You could just put a lid on there, but I'm not going to have the lid on just so we can get a bigger effect. Okay, so at 0 I'm going to plot my point, and you can see it goes on. It's 80 degrees on the graph. So this is a graph here of time on the x-axis in minutes and temperature in degrees C. So you would either plot, get your results and put them in a table and do that, or you could just plot them directly onto a piece of graph paper. When you are plotting points as well, when you're plotting your own points, you probably wouldn't put a blob like that. You would put a cross. So you put a cross to make it really precise where you're marking your point. Okay, so that's at 0 time. Let's go up. Let's go 5 minutes each time. At 5 minutes, you can see that the temperature has gone down, and it is just under 60 degrees, so 59 degrees after 5 minutes. After another 5 minutes, it's gone down to 46 degrees. No, what's that? Yeah, 46 degrees. And then another 5 minutes. That is on, 37 degrees. And it's going down. You can see I'm getting this nice curve. And that goes down to 31 degrees. And we put another point there at 27 degrees, is it? And you can see that the curve is sort of smoothing off. That's because when the temperature difference is the greatest is when we're going to get most heat energy transfer. And as it gets closer and closer to 20 degrees, which it pretty much is now, we're not going to get any, we're not going to get a smaller and smaller amount of heat loss because the difference in temperature is smaller. Okay, so you're going to get a graph that looks a little bit like that. So that was with no insulation at all. You would do this with a range of different insulation layers of insulation. So here you can see I can go up to 10. So I am going to just go straight for 10 just so you can compare the minimum and the maximum, and we're going to do this again. So let's go. I'm just going to do it really quickly, and then you can just see what the difference in the points are. Okay, so you can see already that the temperature isn't going down as quick. Because there's the insulation there, and the insulation isn't allowing the heat energy to transfer through all those different layers of insulation, and so the temperature is staying higher for longer. Okay, so we've had 0 insulation in this bottom line, had 10 layers of insulation on the top line, and you can see the difference. So the kind of conclusion that you would be making from this would be looking at your starting temperature. And if we talk about variables for a second, so we've said that our independent variable here is the layers of insulation. That means that all of the other different variables that I've got must be control variables. So that's the starting temperature, that's the mass of the water, that's the room temperature. All of those things, that's the time that I'm doing it over, they've all got to be the same to make this test fair. And so here I started at 80 degrees. 80 degrees for the 0 insulation went down to 20 degrees. So we had a temperature drop of 60 degrees over an hour. And here we had a temperature drop going down to 29 degrees. So we had a drop that was of 51 degrees over the same time. And so you can see that having the 10 layers of insulation it was more effective than having no insulation at all. So you'd do a comparison of that, and then you'd be able to read off some results. So it's all about practicing your different practical skills, reading thermometer here, drawing a graph, and all of those kinds of things, and then being able to analyse this graph at the end. Okay, so that's just a really quick run through of this experiment. Hopefully you'll be able to actually do this one live in the real life, but if not, then you might be able to have a go on this Focusy learning software, which is a really good alternative to it as well. Okay, right, well that's it for this lesson, for this video. I've been Mr. Baker, and I will see you next time.